This is the parts inventory display team 1, and here's a quick demo of our project. So my focus and part of the project was to make the GUI. I broke it down to 3 main sections: quick search, specific search, and recent searches. So if we go into quick search, there's 10 options to choose from. So if I were to click resistors, it'll first show where all the resistors are. Then I click quarter watt, and then it shows 3 ranges for me to select from. And say I want a 1K resistor, and boom, that's the box that the 1K resistor is going to be a part of. And that works for all 10 of these sections. Some of them go into different levels and deeper, but yeah. And then so Will, his main focus was the specific search. Go ahead, take it away.
So the specific search, you can look for a specific part number. So for example, if we're going to search by part number, we click here, and then we're going to search Jeff's favorite part, the 2N3904. And then what this is going to do, it's going to parse through a dictionary on the spreadsheet. It's going to search for it, and then it will find the box where the 2N3904 is. You can also send this to the recent search, and then if you go back to the specific search, you can also search for a description of what you want. So if you want a multiplexer, you can type that in, and then it will search a dictionary for multiplexers. And then, yeah. And then it will eventually find it once it parses through all the descriptions. All these entries will go into the recent search, which is something both me and Dylan collaborated on. It'll go home. Looks like it queued up multiple multiplexers.
Yeah, must have.
Third multiplexer.
I think because you clicked it like
I clicked it
4 times.
That'll
that
happen.
takes like
Get to know the server
10
works.
seconds.
Yeah, I was gonna say at least it's accurate.
Yeah, so this is a good demonstration of the queue working correctly.
Mm-hmm.
So if we go to the recent search, you can see that we searched the 2N3904. You can click it, and it already knows where it is. So if we go home, we can go to the animations, and Andrew will talk about how the lights work.
Actually, before I talk about how lights work, Gabe's going to talk about how the communication works.
Sounds good.
So we have 2 Raspberry Pis in our project, one running the kiosk display for the user to do input, and the second is running the LEDs. This LED Pi is running a development Flask server, and you can see on the display there that every time it receives a request from the other Pi, it displays it on the screen there. 200 just means okay, so that means everything's working flawlessly.
So once the Raspberry Pi hooked up to the LEDs gets a request, it sends a Python checks to see what the request is, and then based on what the request is, and so far we have all the LEDs mapped out in a file, and it parses through to see where that particular part is, and then lights up the corresponding LEDs. And then we also added cool animation functions, one being a roulette wheel. So a user would select a random box and would run the roulette wheel and hope that it would land on their corresponding box. And now Evan will talk about the hardware.
Okay, now in order to make all these LEDs run, obviously you need to have the right amount of current draw going through here. It is 5 volts, because 5 volts is the best way to make them addressable on here. So what you need is a couple of PCBs that are wired up in order to send data signals through there, power and ground. And we needed 2 of them because for about 99 feet worth of LED strips, which is what we ended up needing, you need about 10.8 amps or so. So you need 5 volts, a 5 volt converter from AC, and needing about 10 amps worth. So I got a couple of power supplies that would give us about 12 or 13 in order to give us the right amount of current. And from there, it's just nothing but splicing and just making sure everything's not grounded out, making sure all the connections are solid. And that is our project. So that's it.